In this video, we're going to take a look at esters, which are actually made of organic compounds you already know. So here we have an ester. This ester has two parts to it. There's a part over here, and then, well, let's count the O in there, and then a part over here. And so those two parts come from two different classes of organic molecules. An ester has the general formula RCOOR. So it's basically you have a carbon chain connected by essentially a carboxyl group, the C double bond O, to another carbon chain, whether it's of the same length or a different length. And so how are these made? They're made by a reaction called an ester synthesis or esterification, sometimes also called condensation, because water is produced. And so what happens is you take a carboxylic acid and you make it react with an alcohol. And to do that, you actually need some concentrated sulfuric acid and heat to just speed the reaction up. This is used as a catalyst as opposed to a reactant, which means that it's something that speeds the reaction up without really being part of the reaction itself. But anyways, what's happening is you'll notice that the alcohol, the carbon chain in the O region, is now connected to the RC double bond O of the carboxylic acid. And so this is your ester over here, and then you have some water produces a byproduct. And again, that's why it's called condensation, because that water produces a byproduct. We'll see this in more detail later on, but just get that you combine an alcohol with a carboxylic acid and you get an ester. So as I mentioned, esters have two parts to them. They have the part that comes from the carboxylic acid, and that's called the carboxylate. And then they have the part that comes from the alcohol, and that's the alkyl group. So what you want to do when you're naming an ester is you want to name the alkyl group first. That's the part that comes from the alcohol. And if it's not attached to the first by the first carbon, you'll state the position of attachment. So is it on carbon number 2, 3, or 4? And then you're going to name the carboxylate part, the part that comes from the carboxylic acid. And rather than name it as a carboxylic acid, you're going to change the ending to O8. So instead of pentanoic acid, it's pentanoate. And then if there's any substituents on that, just make sure that you list the substituents before naming the parent chain. So let's go into a few examples together. So here we have a ester, and I know that because I have the C double bond O with the O here, and then there's carbon chains on either side. The shortest chain is not necessarily your doesn't have to be your substituent. It could be your parent chain. The parent chain really is the part that comes from the carboxylic acid. So that's this part here. It's from our carboxylic acid. So that means this is actually the parent chain here. Our alkyl group, so to speak, is this part over here, which came from the alcohol, because it doesn't have the double bond O on it. So this is going to be named, this is a 4-carbon chain. So that's going to be butyl. We're going to have space. And then this is our parent chain here. Instead of ethanoic acid, it's going to be ethanoate. So we can try drawing one out. Propyl 2-methyl butanoate. So our carboxylic acid part has 4 carbons. So we have 1, 2, 3, 4. Our alcohol part has 3 carbons because propyl. So 1, 2, 3. We can put in the H's as needed. And on the butanoate, there's a methyl on carbon 2. So this is carbon number 1, 2, 3, 4. So this is carbon 2, CH3 here. And so we have H3, H2, H, and that's it. So there we have our ester drawn based on the name. Next, we're going to try propyl hexanoate. So our carboxylic acid region is the hexanoate part. So we'll do 6 carbons, 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. We'll put our double bond O here, or O here. And then our alkyl group, the alcohol part is 3 carbons. So 1 there, 2 there, 3. 1, 2, 3. And so we have propyl hexanoate. Now at this point, you can probably start drawing some on your own. And also naming some on your own. So pause the videos, then check your work. Phenyl pentanoate. So our parent chain is the carboxylic acid part has 5 carbons. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Double bond over here with an O over here. And then the little alcohol group is a phenyl. Phenyl, remember, means that you have your benzene. And there we have it. Phenyl pentanoate. Okay, next you can try naming this one here. It looks like the carboxylic acid group is this one over here. So our parent chain is an ethanoate parent chain. And then the alcohol part is this part here. It looks like it's going to be a hexyl. But remember that this is a cyclic ring. So it's a cyclohexyl. And then we have ethanoate. Okay, let's go ahead and try this one here. Here we have the carboxylic acid end over here and the alcohol end over here. So let's go ahead and name the alcohol end first. So 1, 2, 3, 4. So that means we have butyl. Now we have to name our parent end, but don't forget we have some substituents over here. So we have carbon number 1, 2, 3, 4, 5, 6, 7. So it's going to be heptanoate, but on carbon number 3, there's bromine. So we have 3 dibromo heptanoate. Okay, so now we have these last 2 to name here before we get into some challenges. So the carboxylic acid end is over here, and the alcohol end is over here. The alcohol end has 1, 2, 3, 4, 5. So we have a pentyl molecule, pentyl alkyl group. And then the carboxylic acid end has 1, 2, 3, 4, 5, 6, 7. Pentyl heptanoate. Okay, let's take a look here. So our carboxylic acid group is over here. And notice, though, that this time our alcohol group is over here, but it's not attached at carbon number 1. It's attached to carbon number 1, 2, 3, 4, 5. Carbon number 2. So we have a 2 pentyl. And then the parent chain is 1, 2, 3, 4, 5, 6. Hexanoate. Hexanoate. Great, so at this point we named esters and drew some esters out. We know what esters are now and how they're made. They're made by an alcohol reacting with a carboxylic acid. And there's 2 parts to it, the carboxylate part, which is the O8 chain, and then the alkyl part, which is from the alcohol. And we don't really have sort of a parent chain this time. It's more, there's the carboxylic acid part you name as the O8, and then before that you name the alcohol part as the alkyl group. So just remember that when you're naming esters. So now I want you to try these challenges here. Pause the video and try it yourself. And then afterwards, you can unpause and see if you're on the right track. So here we have an ester. It looks like the carboxylic acid region's here. It has a substituent on it. This is the alcohol region over here. So there's 2 carbons, 1 and 2. So that's an ethyl group. Now we have to name our substituent first. So 1, 2, 3, 4. 3 methyl butanoate. All right, here's our carboxylic acid region over here. Here's our alcohol region. We have 1, 2, 3. Interesting. This time there's a chloro on it. So we now have to combine our knowledge here of substituents on the alkyl group. So we have 3 chloro, 1, 2, 3, propyl and then 1, 2, 3, 4, 5, 6 hexanoate. Again, as you get more practice with the basics, you'll eventually be able to do more complex ones like this. If you didn't quite get it, but you understand the name now, you'll be in a better position to get it the next time around. So if you think that doing these two problems has helped you understand it more effectively than before, try redoing the third one before we take it up. All right, so it does look like we have an ester. That's my first strategy. Is part of the strategy is identifying the ester region there. And it looks like this is the ester part over here. So it's 1, 2, 3 carbons long with a substituent. So I do have to name that substituent. And then we have this alcohol part over here with a hydroxyl group on it. So I need to sort of find the longest chain and then go from there. So it looks like I have 1, 2, 3, 4, 5. 5 is my longest chain there. And I have to start by naming these substituents in the proper order. So I know I have a bunch of methyls and then a hydroxyl. So hydroxyl comes first, 3-hydroxy, and then 2,2,4 trimethyl, 2,2,4 trimethyl, and then space. So I'm running out of room here, so I'm going to do a space. I'll just write below here. And I have to name my carboxylic acid part, so I have a 2-methyl, and then propanoate. This is a complex one because your alkyl group had substituents on it. So you had to just kind of apply the same rules before and to just bring it into the ester sort of rules that we have there. So in the last video, we're going to take a look at properties of carboxylic acids and esters to compare them to other molecules. And at that point, you'll have seen how to name carboxylic acids and draw them, as well as esters, name and draw, how they're produced, and then also their properties. And you should be able to explain their properties with the help of intermolecular forces based on their structure and functional groups.